Welcome to this first Oracle Machine Learning Office Hours of 2025, getting started with Oracle Machine Learning on Autonomous Database. So I'm Mark Hornick. I lead the in-database machine learning and select AI product management, and I'm joined by Sherry LaMonica. Sherry, please introduce yourself.
Hi, I'm Sherry LaMonica, a consulting member of technical staff in the Oracle Machine Learning product management team at Oracle.
So in today's session, we'll give you an overview of the Oracle Machine Learning family of components on Autonomous Database, interspersed with a few product demonstrations to help you get started. And we'll also touch on some of the newer 23 AI features. As you'll see, the feature set is extensive and we'll just be scratching the surface. But in future office hour sessions, we'll take a deeper dive into various topics of interest. Before we begin, though, I'd like to take a brief poll. To gauge your experience with OML, which of these products or features have you used? And please select all that apply. Okay, well, it's good to see that we have virtually everyone is an Oracle database user and very close to everyone being autonomous database. We've got the R, Python, and SQL, about 40%. Notebooks, close to 50% for that as well. AutoML UI at 24%, and the data model monitoring 15%, and OML services about a quarter of you. So that's great to see that you have some experience with that, at least some of you do. And for those of you who haven't tried these out yet, we'll be giving you an overview and introduction to some of these, and we'll explore those further as we go into other sessions. So thanks again for participating. Now, since our focus is Oracle Machine Learning on Autonomous Database, I'll give you a brief intro to Autonomous Database, just in case you're new to it. You can think of Autonomous Database as Oracle Database reimagined for the cloud, automating the database management lifecycle, providing mission-critical database support for performance-engineered systems, and folding in database management best practices, AI, and powerful tools. Now, you also have a broader range of deployment choices for your cloud and data requirements. Autonomous Database runs where you need it, whether that's Oracle Cloud, Azure, Google, or AWS. And you can use in-database machine learning in these environments as well. Now, what do you expect from a platform for data science and machine learning? Well, of course, such a platform needs to provide data management, a hallmark of Oracle Database. And you want development tools, machine learning, graph, spatial analytics, semantic similarity search, vector database functionality, as well as access to generative AI. Data and model monitoring is important, as is support for security and compliance requirements. And you want to easily provision infrastructure and access to powerful visualization and reporting capabilities. And as we'll discuss, such features are provided with Oracle Autonomous Database. Now, this brings us to the focus of today's session, Oracle Machine Learning. We've placed powerful machine learning algorithms directly in the database, which helps you achieve rapid solution development and deployment to applications and dashboards. OML eliminates costly and risky data movement for database data, and it avoids separate analytical engines, which can simplify your solution architecture, as there's no need to manage and test workflows involving third-party engines. It delivers over 30 scalable in-database algorithms accessible through multiple language interfaces, including SQL, Python, and R. And you can easily use OML with the broader Oracle stack, like Oracle Analytics and Apex. And OML is included with Autonomous Database instances and Oracle Database licenses, so you can just start using it. Now, Oracle Machine Learning has been evolving for over 2 decades, and we started with the acquisition of a company called Thinking Machines in 1999, and several of us joined Oracle through that acquisition. As you can see here, we've continually enhanced the machine learning capabilities available in the database. So what types of business problems or use cases can you address with machine learning? We often think of industry-specific vertical use cases, but there are surprisingly many that cut across industries, what I'll call horizontal use cases. Most enterprises have customers, products, equipment, and employees. And here we see a range of use cases that we could apply to customers, from customer segmentation and churn prediction to lead generation and fraud detection. For products, what products should we recommend to our customers? Perhaps we want to forecast demand, inventory, and revenue. On the equipment front, consider predictive maintenance. If we service equipment too soon, we're wasting money. If we service it too late, we could incur more expensive repair costs or even need to replace the equipment. And finally, with employees, what are the attributes of our best employees? And can we predict, which are likely to leave or what our hiring needs will be? Now, these use cases can be addressed using a range of machine learning techniques. We'll start with classification, a technique that we can use, for example, to predict customers with high lifetime value or who are likely to prepay their loan or perhaps default on their loan. Other use cases can include predicting which vehicles need maintenance, whether a customer is likely to churn, or which customers we should prioritize with marketing campaigns. Now, a second technique, regression, could also be applied to some of these same classification use cases, but adapted to predict a numeric outcome. For instance, instead of predicting lifetime value as high, medium, or low, you want a monetary value that could be summed. Other regression use cases include things like forecasting product demand, sales, or revenue. And of course, time series provides another class of algorithm that could be applied to these same use cases, depending on how data is organized. Clustering, on the other hand, helps with customer segmentation and document classification, which overlap with the classification technique. Association rules, you might use that for cross-sell and upsell opportunities. And anomaly detection, of course, that's useful for transaction or claims fraud detection, or just identifying unusual cases, which may signify the need for closer inspection of your data. And of course, these examples just get into the very basics of what's possible with machine learning. Now, OML supports the use cases just highlighted and others by providing a rich set of algorithms across multiple techniques. You might ask, why do we have multiple algorithms for a given technique? Well, some algorithms are better at finding certain types of patterns in data than others. Some offer a greater degree of transparency to understand those patterns, the insights that were discovered. And each has its own computational demands, meaning that some are faster than others. But what makes these algorithms different from those you can get from open source packages or other vendors? Well, here are a few differentiators. Now, in database parallelized algorithms, well, this means that there's no need to extract data to separate machine learning engines, which can be time consuming and affect performance and data security. These algorithms have been reimagined, redesigned to offer scalability across cluster nodes and optimize memory use by not requiring all the data to be loaded into memory or build models. Scoring, or inferencing, can take advantage of the Exadata storage tier function pushdown optimizations for even faster inferencing, especially for large-scale batch scoring. In-database machine learning models are first-class objects in the database. And that means that, like database tables, you can control access by granting and revoking permissions, audit user actions, and export and import models across databases. Once you build a model, it's immediately accessible through SQL queries. And as a database object, models are part of database backup, recovery, and security. As a result, be a lot faster to deploy machine learning based solutions. And you can use the prediction operators in SQL queries, make predictions from R and Python, and deploy models using no code and REST interfaces. So this table provides a quick summary of the OML components and where they're available. Note that all of the components listed here are available with Autonomous Database Serverless and Dedicated Region. And as we've already noted, OML provides support for in-database machine learning across the top three data science languages, SQL, R, and Python. OML for SQL enables building models using a PL/SQL interface and scoring data or inferencing using SQL queries. More recently, it also allows you to import ONNX-format models to the database for use from SQL queries, leveraging the in-database ONNX runtime. Now, OML for R and OML for Pi allow you to manipulate data and build machine learning models directly in the database, using what we call data frame proxy objects with native R and Python syntax and functions. You can also invoke user-defined R and Python functions in database spawned and managed engines, even invoking R and Python user-defined functions from SQL and REST. Now, Autonomous Database Serverless also provides a built-in notebook environment and no-code user interfaces for AutoML and data and model monitoring. OML Services supports model management, deployment, real-time scoring, as well as monitoring and data bias detection using REST endpoints. And Oracle Data Miner, our first user interface, is a SQL developer extension with a drag and drop interface. So before going further, Sherry will walk us through gaining access to Oracle Machine Learning and its user interface on Autonomous Database. Sherry?
Okay, so this is my Autonomous Database in the Oracle Cloud Infrastructure, or OCI console. And I navigated here by going to cloud.oracle.com, and I logged in using my OCI username and password and selected my Autonomous Database. And here you'll find database details like the database name, which is OMLLA, the database version, 19C, and other information. One of the first things I might want to do is create a database user or enable an existing user for OML. So I go to my database actions, and I'm logged in as admin, so I have access to administration and database users. And this is where I can enable an existing user for OML or create a new user. Call it OML user, enter my password that I want to use when logging in. I can give the user unlimited table space on the user table space, which is data. And then the only thing that I need to do is toggle this OML button, and this user will have OML access. Okay, so if I want to, now I have a database user, very easy to onboard a new user. I go to database actions, and now I want to access the Oracle Machine Learning UI. So I go to development from the Launchpad here and Oracle Machine Learning, and I can log in with my user. I will log in as OML user. And this will bring us to the Oracle Machine Learning user interface. So under what's new, the banner at the top, we regularly add new features and updates, and this is where you'll learn about them. Under the navigation overview, under How Do I, we have links to documentation and a live lab where you can test drive the OML functionality, and recent activities down here for easy access. And under quick actions, we have direct links to some of the commonly used features in OML, which can also be accessed through this 3-line menu. So we'll go over that in the next demo, but accessing your OML UI and Autonomous Database is straightforward. You just sign into your database through Oracle Cloud, set up a user account with OML enabled, and launch the OML UI. Back to you, Mark.
Thanks, Sherry. All right, so let's highlight a few more components and then demonstrate some, as Sherry mentioned. Now, OML Notebooks provides a collaborative user interface with built-in SQL, PL SQL, R, Python, Conda, and Markdown interpreters, and it provides customizable built-in data visualizations. You can import and export Zeppelin and Jupyter notebooks, as well as explicitly share notebooks and templates, version notebooks, and schedule notebooks to run at a set time or on a recurring schedule. And you can use third-party and R Python packages in OML Notebooks through custom-created Conda environments. We've also enabled using GPU compute resources with the Python interpreter and GPU-enabled packages, which you configure through the custom Conda environments. As you'll see, OML Notebooks provides a library of template example notebooks that illustrate the various OML features. And you can also schedule notebooks to run with email state change notifications like notebook completion. But let's take a brief look at the SQL R and Python interfaces, starting with OML for SQL. OML for SQL enables you to build and evaluate machine learning models using the in-database algorithms from a PL SQL interface, and then use those models in SQL queries. And this is supported through the DBMS data mining package. Each model provides what we refer to as model detail views, and these expose various aspects of the model, including quality metrics, metadata, and patterns applicable to each model. Now, new to OML for SQL is the ability to use vector embeddings as input to several of our in-database algorithms. To support bring your own model to the database, you can import ONNX-format models, including text transformers, and in 23 AI 23.7, image transformers. And this is for use in SQL queries using the in-database ONNX runtime. And such transformers are also used with AI vector search. Now, ONNX, or the Open Neural Network Exchange, in case you're not familiar with it, is an open source representation of machine learning models. That works not just for neural networks, but other model types as well. Now, let's look at an example of building a classification model to predict customer behavior. In this case, whether they'll buy travel insurance. Using the DBMS data mining procedure create model 2, we provide a model name of buy travel insurance, which we can later use in SQL queries. The data is provided using a query here, select star from customers. And from our settings list, we specify the support vector machine algorithm. Our target column, what we're trying to predict, is buy travel insurance. And when we use this model, we can use the prediction operators built into Oracle SQL. Here, we're doing a singleton score using the prediction probability operator on the buy travel insurance model. And we're providing the predictors directly in the query. Of course, we could also perform large-scale batch scoring on all the records in a table and either materialize them through a create table as select statement that results in a full-fledged table, or access the scores dynamically through a view. Now, there are several other features of in-database models, such as explanatory prediction details. And I'll just mention this briefly because it allows you to identify which predictors contribute most to a given prediction. For example, in the first row of the result, the customer is predicted to buy insurance. And the predictors, a year of birth and year's residence, are the top 2 predictors for this customer, along with the specific values and importance weight given. And one other feature I'll mention is what we refer to as partitioned models. Here, OML automatically partitions data using one or more columns, and it builds a submodel on each partition. All the submodels are provided to the user as a single unified model that can be used directly for scoring. The system determines which submodel should be used based on the values provided in the partition columns at the time of scoring. It does this automatically. Now, next, we'll highlight OML's native interfaces for Python and R languages. Using OML for Py and OML for R, you take advantage of Oracle Database as a high-performance compute engine using proxy objects and function overloading, where you can use familiar Python and R syntax for exploring and transforming data. The API enables using the in-database ML algorithms through native Python and R interfaces. In the Python API, you also have access to automated machine learning, or AutoML. You can store and manage your Python and R user-defined functions and objects in the database, as well as invoke user-defined functions from SQL and REST using database-spawned and managed Python and R engines. You can also incorporate third-party packages into your solutions. So we've already seen the PL SQL interface for building a model, but let's briefly contrast this with the R and Python interfaces. So on the right, we get a data frame proxy object for the customer table. And we set the model name to my travel insurance, and then build a model using the R function that invokes the in-database SVM algorithm. We're using the R formula syntax to specify the target and the predictors. We specify the proxy object customers and the settings. Below that is a Python example. Again, we get a proxy object to our customers table, and we can separate the predictors from the target, as is the Python convention, but there are other ways of specifying that as well. And you create an SVM model object, fit that object with the data and our desired model name. Now, each of these produces a model in the database that can be used from their respective interfaces. And as we're showing here, you can do that through a SQL interface as well, using the prediction probability operator that we saw earlier. Now, as I mentioned a moment ago, you can store Python and R objects in the database. And using these functions, this avoids having to store native R and Python models in flat files. Instead, you can keep everything unified in the database with security, backup, and recovery. So let's look at OML notebooks in more detail and instantiate one of the template notebooks that uses OML for SQL. Sherry?
Okay. So each user begins with a personal workspace containing one project, and from there you can create additional workspaces and projects, as well as manage sharing permissions to facilitate team collaboration. Here we're using the office hours project in the OML workspace. So let's navigate to our template examples. The three-line menu, templates and examples. Here we have over 100 examples for you to either look at in read-only mode, or you can instantiate a notebook from them and run it in your OML notebook view. This one. So if I wanted to just look at this in read-only mode, I would click on the title. Instead, I'm going to select this template notebook and select Create Notebook. And it's going to create a notebook in my notebook listing in this project. I can add a comment if I'd like. And when this is available in my notebook listing, I can run it. Okay, I can either open the notebook directly or go to the three-line menu and select Notebooks. And here's my notebook listing. You can see I already have a notebook in here, time series ESM. But if I wanted to open the one that I just instantiated, I would click the title. Let's open the existing one. And here's my notebook. So I'm going to select this button to run all of the paragraphs in this notebook. And while the environment is getting set up, I will show you a few things. You can run an individual paragraph with the Run Paragraph, a button on an individual paragraph. You can version your notebook, clear the results from all of the paragraphs in your notebook, clear paragraph dependencies if you've set those up, export the notebook in the native format, which is Oracle Data Studio or Zeppelin and Jupyter, print the notebook, and select a notebook service level, low, medium, high, and GPU. And these correspond to different levels of database parallelism. GPU is the highest, and that's where you can use GPUs. Okay, so let's go through the notebook. The first thing that I might want to do is create a new paragraph. So let's do that right here. So I have options for Python, R, Markdown, Script, which is PL SQL, or Conda for third-party package usage. So let's just add a Markdown right here. And maybe I just want to say hello. And I can add a comment on this paragraph if I'd like. Run it. You can delete the comment, but that green indicator indicates that the paragraph has a comment. So that's good for collaboration with team members or even just reminders to yourself. So let's quickly go through this notebook. This is Oracle Machine Learning for SQL time series. And first I'm creating a view for model building and looking at the data, looking at the number of records and doing a select on the data, ESM SH data. Here is my model build. I'm first dropping the model if it already exists. The model name that I'm giving it is ESM Sales Forecast 1. And then I'm using the settings that I'm passing to the model and I'm putting them in a setting list. So the algorithm name, the prediction step and seasonal cycle are 4 quarters, and the type of model that I want, which is Holt Winters. And then I'm using the create model to procedure to build the model. So the model name, I provide that, the mining function, the table that I want to use, pass the settings list, and then the target and case ID. You can look at information about the model, like the model diagnostics and quality, forecasting using the SQL prediction operator. And then down here, I have a chart that is forecasting the amount sold values. And I can, with confidence intervals, and I can hover on the legend to see each specific line in the line plot. There are other types of plots that you can use here. We're using this line plot. You can also toggle over just to see the raw data if you'd like. Okay, so the other thing that I can do is I can import a notebook into my notebook listing. So let's do the import. The Data Studio notebook that's running OML for Pi. And then I can open that up and run it if I'd like to. But it's in my notebook listing now, so I can upload it from my file system. Okay, so we have this collaborative workspace experience. We allow users to work with Python, R, and SQL, and PL SQL and Conda environments in a secure environment. And users can leverage pre-built templates, use version control, and flexible import and export capabilities to streamline your workflows. Back to you, Mark.
Okay, thanks, Sherry. So, as I mentioned earlier, one of the features of OML for Pi is automated machine learning, or AutoML, to simplify the modeling process. Now, AutoML supports automated algorithm and feature selection, as well as automated model tuning and selection for classification and regression. And the goal is to enhance data scientists' productivity and help non-experts produce reasonable machine learning models also. Now, it eliminates the repetitive and time-consuming tasks of building and evaluating models, and users don't need to understand how to tune individual algorithm hyperparameters, which can be rather complex. Now, also in support of AutoML is a no-code user interface. You select the prepared database table and the column you want to predict, specify a few optional details, and click Start. The AutoML UI builds and compares multiple models with model quality metrics, and you can also generate a notebook for individual models that provide the AutoML determined hyperparameters along with the basic structure, sort of as a starter notebook. And through this no-code user interface, you can also deploy individual models to OML services, which I'll say a little bit more about later, for use through REST endpoints. Of course, once the models are produced, you can immediately use them through SQL queries. And so let's have a quick demonstration of the AutoML UI and generating a notebook for one of these models. And this starter notebook, as you'll see, uses the Python API. So back to you, Sherry.
Okay, so from my notebook listing, I have two ways that I can get to the AutoML UI. I can go from here down to AutoML experiments, or I can go back to the home and go to the quick actions and select. So I have a couple of experiments here already, but I'm going to create a new one called Credit Scoring 3. And I can add a comment, but I'm going to select the data source, Credit Scoring 100K. That's in my schema. Okay, then I'm going to select a case ID, which is customer ID. And then the target that I'm predicting is credit score bin. And the prediction type is automatically selected based on the column type, either a classification or regression. Under additional settings, I have some options. I can reduce the number of, or increase the number of maximum top models, choose a database service level corresponding to parallelism, which is medium, the model metric, and then I can, deselect algorithms if I don't want them considered in my list. We have all of the features. I can deselect a feature if I don't want that included in my analysis. And then I just start the experiment. I'm going to start this with faster results. So faster results tries fewer what we call pipeline combinations, whereas better accuracy will try more pipeline combinations, and that consists of data algorithms and settings. So while this runs, you'll see the progress bar and the workflow steps start to to populate. And the leaderboard is also updated as the models are built and the highest performing model for each algorithm is found. So we'll let this run for just a second. And you see the leaderboard is starting to populate. So let's go back to, while this runs, let's go back to one of these that is already built. Okay, so once the model is built, you can select one of these models. I'll select the top model. And you can look at the prediction impacts, the top prediction impacts, and the confusion matrix. And you can go in and see the feature importance if you'd like. And there's a couple of things that we can do. So you can deploy any of these models, which are in database models that are produced by these experiments, to OML services for accessing REST endpoints by hitting the deploy button. But what I'm going to show you is how to create a notebook that builds this model. So create notebook. This is going to be the name of the notebook. I can change it if I'd like to. And this generated notebook will show up in my notebook listing. So let's just open the notebook directly. And I'll run the whole thing so that you can see what this looks like. It's using OML for Pi. And the experiment it's setting up the running environment. So this is what we have here. I'll show you the workspace where this was run, that it was an AutoML experiment. And then get your proxy object for the selected data. We work with proxy objects to interact with database data. Preparing our training data. Here you can see the hyperparameters that were used to build the model. Model details. Scoring the data using the overloaded predict function. And then the model quality metric. And of course, you can add more paragraphs and augment this notebook as you choose to. You can also use the models that are produced from experiments directly through SQL queries for interacting with your enterprise applications. Of course, Oracle Analytics Cloud, Oracle Apex, basically any tool that can invoke SQL queries. Okay, back to you, Mark.
Thank you, Sherry. So let's continue with OML services. Now, OML services provides MLOps support on autonomous database serverless, where you can manage and use machine learning models from REST endpoints. This includes model management, deployment, data and model monitoring, as well as data bias detection. On the scoring front, OML Services provides lightweight scoring using REST endpoints, making it appropriate for real-time and streaming applications. Not only can you deploy in-database models in native format, but you can also bring your own ONNX-format models, perhaps produced in a third-party environment, and import them into the database for use through the same REST API. Now, for this, OML Services supports classification, regression, clustering, and feature extraction models. Now, in contrast with other machine learning model deployment approaches, it's important to note that with OML Services, you pay only for the actual scoring compute. You don't have to provision a separate VM and manage and pay for that VM 24/7 to support your applications. Now, on the theme of bring your own model, you can also import text and image embedding models to your 23AI database. And these can be used in combination with AI vector search. Using the OML util package, you can easily generate a portable ONNX-format model from a Hugging Face repository. And you can then save this model to the database for use with the in-database ONNX runtime. There's also a PL/SQL interface through the DBMS data mining package. And here you provide a pre-created ONNX-format bundle to import to the database. And we call it a bundle because there are certain pre- and post-processing steps that are required to use your model in the database. Now, to put this in context, here's a quick example of how you can use such imported transformers for document similarity search. Consider that we want to get the top 10 job posts for a software engineer in New York ordered by the resume's semantic relevance. Well, we take a text document, convert it into one or more vectors, and search our vector database to retrieve the relevant job posts. So let's see the code in a simple example that uses the Oracle AI vector search with this model. We first need to create our table of vectors. And we use the vector embedding operator and our sentence transformer that we created earlier to create an embedding for each job post. And there are, of course, more sophisticated ways of chunking documents, but we're keeping it simple for illustration. Next, we create a vector index on our newly created vector column embedding. Then, we can write a SQL query that allows us to combine structured data, filtering those values, with the vector distance operator, where we pass in our resume text to produce a vector embedding and compare that against the embeddings in our index to find the most relevant job posts. Now, in addition to embedding models, you can also import classification, regression, and clustering models to use the in-database ONNX runtime. Now, these types of imported models behave like native in-database models, and they can take advantage of the same prediction operators that the in-database models can. So in this example, we retrieve the ONNX-format model from object storage and use the import ONNX model procedure to store the model in the database. And then we can use a SQL query and the prediction operator to use our new model. In this case, it's a churn model. Now, also available through OML Notebooks are the OML for Pi Spatial AI machine learning algorithms. So, in addition to the traditional spatial analytics that you already have in the database, you may want to use such data to identify things like where crimes are clustered or unemployment hotspots. As you can see, you can get some impressive visualizations with the results. You can leverage a variety of machine learning techniques and corresponding algorithms to work with spatial data directly in your database, as we're highlighting here, from classification, regression, clustering, anomaly detection, and feature engineering. So before we wrap up, we'd like your input to help us plan next sessions. Which topics would you most like to see in upcoming OML office hours? Please select, say, the top 3. And if there are other topics that we don't have on this list, please feel free to include them in the Q&A or chat. Okay, we're getting some good feedback here. I think the leaders here are OML Notebooks and OML for Pi. We have OML Notebooks with over half interested in hearing more about that. It's almost half for OML for Pi. About a third of you are interested in more about OML for SQL. The AutoML UI has about a third. We're seeing bring your own model. That's close to half as well. So OML services, about a third of you. So we'll be planning these as we go forward, and we look forward to you joining us for that. So thank you for giving us your feedback. So to summarize, OML allows you to have a simpler solution architecture, leveraging Oracle's converged database. By virtue of being part of the database, the machine learning functionality is immediately available to you. And on Autonomous Database, you have a wide range of built-in tools at your fingertips. You can eliminate data movement for database data and use multiple language APIs, including SQL, Python, R, and REST. And you can take advantage of AutoML, data and model governance, and scalable modeling, even with elastic scaling on Autonomous Database. Using OML, there is a simple pricing structure. Machine learning capabilities are included in the core product at no additional cost. In addition, you have flexible options for development, test, and deployment in the cloud, on-premises, and hybrid environments. And with support for multi-cloud environments, you can operate not only in the Oracle Cloud, but also Azure, Google, and AWS. So for more information, here are a few resources. You can check out our machine learning blog. We have live labs where you can quickly spin up an autonomous database and try out the features that we've talked about, as well as see our product documentation linked here. So thanks for joining us for this session on Oracle Machine Learning. Next week at this time, We'll be starting an office hours series on Select AI, what allows us to access generative AI capabilities through SQL with Autonomous Database and outside of Autonomous Database as well. Thanks again, and we'll see you next time.